Hello students. So today you are going to take third class on measures of central tendency. So in the first class itself I have already covered the concept of mean, median and mode, and in the second video or the second class I have covered the different ways of calculating mean. What are the different ways of calculating mean that I have explained, right? So in this third class itself you will understand what is actually central tendency and why mean, median and mode, these are the measures of central tendency. That I am going to explain. And to understand that, you need to understand the distribution, data distribution, how does it look like graphically. And there I will plot mean, median and mode, and then you will understand where mean is more important, where median is more important for what kind of data, which is the more efficient measures of central tendency. So it depends on the type of data distribution. Okay, this is a very interesting one. Just look into that. And for the first class, where I have already covered the concept of mean, median, mode, I will suggest you to go through that video first. For what the link is given in the description section below for this particular video. Okay, so let's start. So now look into this table. What is this? In the table there is a first column, that is value, that is the observation, set of observation that is given, and this is the frequency. Let's say the values are given like this in the row format. Let's say the data set of the observation is given like this: 7, 5, 9, 7, 6, 8, 6, 7, 8, 7 in the row format, right? Now I have depicted the entire set of numbers in the tabular format. It will be easier with respect to visibility when you will calculate mean, median, mode. So when the numbers are given in the row format, if the numbers are the number of observations, those are a bit on the higher side, it's always advisable to write down all the data in the tabular form in observation set and frequency set, so that you don't miss any of the numbers by mistake, right? So I have written all the observation along with their frequency in this tabular form. Okay, so now if you calculate, first of all, if you calculate the total number of frequency, because what is the formula of mean, median, mode, that you first calculate the mean, median, mode with respect to this tabular data, and then we will plot it plot it graphically, right? So now if you calculate the mean, what is the formula of the mean? First of all, you need to calculate the total frequency, summation of frequency. What is this? The summation of frequency from the second column of this table, that is 10. What is the formula of mean? Mean is the summation of fx, f is the frequency, x is the observation. So you need to, as you know already, I assume you know already, but still I am saying, so you need to multiply each of the observation along with their respective frequency and sum up all the numbers. That is what I am doing. 5 into 1, 5, plus 6 into 2, 12, plus 7 into 4, 28, plus 8 into 2, 16, plus 9 into 1, 9, and divided by the total number of observation, that is the total frequency, 10. So what mean is coming to 7. So 7 is the mean for this given data set. So now we will calculate median. So what is the median? Median, you know, if the number of observation that is given, then there will be two median. Two median means median is positional data, right? First you need to find out the position for the median. So if there is even number, then there will be two numbers. So what are the positions? Position is, one is n by 2, n by 2th position, and another one is n by 2 plus 1/8 position. All these things I already have explained, right? So n by 2 and n by 2 plus 1/8. So what is n? N is the number of observations. So what is the position for the median data for this particular data set? That is, n means 10, frequency, that is total frequency 10. That means 10 by 2 equals to fifth, that is the fifth data, and another one will be sixth data, fifth and 6th. So 5th and 6th observation. So there are two median, right? 5th and 6th. Now what happens sometimes, so in median you are arranging all the data in ascending or descending order. Here it is in ascending order. I have arranged these numbers. Now 5th and 6th. So these are the position for median data. 5th and 6th. So what is the 5th? First one 5 first, second is 1 plus 2 3, 3 plus 4 7. That means the median data will come in this range. Sometimes in your books you will find out, rather than writing it adding up the frequencies verbally, there is another column that is made, that is called cumulative frequency. CF, cumulative frequency. Cumulative frequency, first one is 1, second one is 1. So you are adding up each of the row with this previous row. So 1, second one will be 3, third one will be 3 plus 4 7, then 7 plus 2 9, 9 plus 1 10. So 5th and 6th term means it will come under this region, because this will be greater than 3 previous row. So 5th and 6th both the term will be 7 value, because 7 has the frequency 4. There are 4 7s, that means 5th and 6th term will be 7. That means both the cases numbers are same, that will be median will be 7. If the numbers would be different, then the average of these two numbers. So in any case the median will be here 7. So median equals to 7. That also you have, you know. Now what you will calculate? You will calculate mode also. So what is the mode? Mode is nothing but the which is the highest frequency, or which value has the highest number of occurrence. 7 has the frequency 4. That means mode will be 7. So now you already found mean, median and mode. Mode is 7, mean is 7, median is 7. Let's plot the data, right? So now let's say I will put this mean, median data graphically. So values that is along the x-axis and frequency that is along y-axis, right? So now 5 has the frequency 1. So if I consider each of the unit as 1, both for frequency and values, so 1 2 3 4 5 and then 5 1. You know, by this time I assume coordinate geometry, right? How to plot data in the graph also. So 1 2 3 4 5, this is 5, values 5, frequency it is 1. Second is value 6, observation 6, frequency 2. Observation 6, frequency is 2. Third is observation 7, frequency is 4. So this is 5. This is 5, this is 6, 7, 8, 9 and 10. And this is 1, 2, 3 and 4. So 7 has the frequency 4. This is how 7. Frequency of 8 is 2. Frequency of 8 is 2. And frequency of 9 is 1. So now if you draw this curve, it looks like this. That is how it looks like. So if this curve looks like this, then how you can point out the mean, mode and median here? So this is the highest frequency, and you, that means if you, and mean is also 7. Mean is also 7. So 7 is mean. And median is also 7. That is what. So that means in this representation, where it is actually coming at the bottom portion, this is called tail. This will never meet this x-axis because in that case your frequency will be 0. So any observation doesn't have any frequency, it doesn't make any sense. So it will go like this. It will go like this. But how the tail will extend? It depends on the number of observations. Here we can see the tail is up to this point. That is 1. Right? And here it will end up. Now, if your values will extend, so in that case it is these two portions. This is called tail. These are tail. And if I consider here mean, median and mode, mean equals to median equals to mode. So this mean, median and mode, all these three are equal, and if I so right side of 7 and left side of 7, that is the right side of mean, median, mode and left side of mean, median, mode, actually these two are equal halves. So this particular mean, median, mode, this is dividing the entire region into two equal halves. That is what called normal distribution. So in normal distribution, that is happening in the centrally. If you see this data, so it is happening centrally. All these mean, median, mode, these are at the central point in the graph. What does it mean statistically? Statistically, it means all the points, if mean, median and mode are equal, that means that is a normally distributed data set. That means wherever is the mean, median, mode, the value, all the values, all the data set that is actually surrounding, this mean, median, mode are surrounded by those data set. That means all the data sets are nearby this mean, median, mode because that is at the central point. So for normal distribution, you remember this term, this is normal distribution. Even though it is not in your syllabus, you just try to remember, then you will understand why these mean, median, mode are called measures of central tendency. For normally distributed data, any of mean, median, mode, this could be the measure of central tendency, and any of these three can represent the nature of data set. If mean, median, mode is equal, all these three are equal, that means it's a normally distributed data. So it's a balanced data set, right? Then I will tell you one more thing here. Now I have added two more observation, 20 frequency 1 and 30 with frequency 1, but these two observation values are significantly higher with respect to the rest of the observation. So these are called outliers. When you have very few observation, those values are significantly higher than rest of the observation, or significantly higher or lower. It could be higher or it could be lower. Significantly higher or lower, in that case those values are called outliers. What is the term? The term is called here 20 and 30, these two terms are called outliers. These outliers are with much on the higher side with respect to rest of the observation values, and it sometimes it could be also, let's say the negative number it is coming, then it is significantly lower side, right? So outliers, these outliers can change the mean. So adding outliers, why it will impact mean? Because while you are calculating mean, you are considering all the observation values along with their frequencies. You are multiplying all the observation values with their frequency and then summing up the entire set of numbers and dividing the entire set of numbers by the total number of observation or frequency. So in that case, for mean, or it will have significant impact if there is the presence of outliers. And how it is happening, I will show you graphically here also. But before that, you calculate the mean also. So earlier, what was the mean, median and mode? Let me write it down here. Earlier, in my earlier observation data set, it's with respect to earlier data set, where 20 and 30 was not there, the mean, median, mode, what were the values? For earlier set of data or observation where 20 and 30, these outliers were not present, the mean, median, mode, the total, all the values were equal. That was the value was 7. Here you calculate the mean. What will be the mean? Mean will be total number of frequency. As we know, here it will be increased. Earlier it was 10. Here I have added 1 and 1, 2. That means summation of frequency will be 12. And what will be the mean in that case? The mean will be summation of fx. Summation of fx means 5 into 1, 5 plus 6 into 2, 12, 17. So 5 plus 12 plus 28 plus 16 plus 9 into 1, 9 plus 20 into 1, 20 and 30 into 1, 30. So total, earlier it was 100, now it will be 100. Earlier it was 70, now it will be 120. 20 plus 30 I have added. So 12 total number of observation. So what will be the mean? Mean will be 120 by 12, that is equals to 10. So mean will deviate because your 20 and 30 data set, it will be far away from 10. That means let's say it will be here and there, something like that, here or something like that. So if I extend the x-axis like this, the 15 and 20 and 30 point, it will be extend like in this direction, this direction with frequency 1. Let's say assume, I am not exactly plotting it in the graph, but assume it will far away like this and this, that's 2 point, right? So in that case, you can see from this particular median, right side and left side, this is no more symmetric. This is the smaller one, this is the larger one, right? So there are 2 points, 20 and 30, and therefore the mean will deviate from 7. Earlier it was 7, it will deviate to 10. So mean will deviate to 10. So here the mean will be this point. This is the mean with the new set of data. Earlier the mean was here. So this is mean M2. Earlier the mean one, it was here, 7. So 7 to 10. So any inclusion of outlier will significantly change the mean. But is it changing the median? It may change or may not change because median is the positional data. So actually median will be changed when the frequency is changing significantly. Here the frequency is changing from 10 to 12. Let's say where the 12th position, so if the frequency total number of observation is 12, that means what are the median terms will be there? Here the median will be, with the new set of data, the median will be 12 by 6 and 12 by 6 plus 1. That means 6th and 7th position. 6th and 7th position. So what is the 6th and 7th position? Again, it is 4. It is 7. Right? Both the observation, 6th and 7th observation is 7. Either you look into the cumulative frequency or straight away without having this extra column cumulative frequency, you can calculate from here also. 1 plus 2, 3. 3 plus 4, 7. That means 6th and 7th position will come within this data set. So 7. So median will still 7. So even though your outlier is adding, not necessarily your median will be changed. But if I add couple of more points here, then the total frequency will be changed. From 12 it will be increased. So let's say a couple of frequency observation I am adding here, whatever is the value. So 14, let's say. So 14 means it will no more come under this particular area, right? So 1 plus 2, 3, 3 plus 4, 7. So 14 means what will be the frequency median position? If the total number of observation is 14, that means n by 2, 14 by 2, 7, and n by 2 plus 1, 14 by 2 plus 1, that is 8. 7th and 8th term. Here it will be 7th term, it is 7, but 8th term it will come under this area. So 7 plus 8. 15 by 2, 7.5, it is changing. So more the frequency will be there, the number could be changed. So impact of outlier is significantly high on the mean, but not in the median. Now, in my earlier distribution, it was the normal distribution where both sides the curve was symmetric, equally distributed. Half this side, half that side. Here we can see majority, even though majority of the observation at the lower side, right? Lower side, very few observation at the tail towards right. So basically this is called positively skewed distribution. It is skewed distribution. And what kind of skewed distribution is it? It is positively skewed distribution. So where you have majority of the observation values at the lower side, but very few on the extreme right, the tail is towards extreme right. Here this kind of data distribution is towards positive direction. The tail is going towards positive direction. So it is called positively skewed distribution or imbalanced data. So to make it balanced data, we can remove the outliers. So if we remove the outliers, what is the impact? Because if you look into next you study few of you may be studying artificial intelligence or machine learning going forward. This is one of the most crucial data processing that you need to understand, where you need to remove the outliers to understand the actual data distribution, majority data distribution, whether it is balanced or imbalanced. Here we can see if we remove these two outliers, 20 and 30, which is significantly higher with respect to the rest of the values, there if you remove this 20 and 30, again this positively skewed distribution, it will come towards normal distribution and the center will come towards this position, mean, median, mode. Again it will be equal. So always the pool is towards the central position. So when for normal distribution actually, so in that case for the positively skewed distribution, what we have seen, the mean is significantly higher. Sometimes when I am adding frequency, the mode will be changed. So mode will be median will be changed, but the frequency, if the frequency, this will not be impacted just by adding values. Always it depends, mode is dependent on the frequency. Let's say whatever number of values I am adding, but the frequency is less than 4, that means the mode is not getting changed. So for normal distribution, let me write it down. Okay, so what we can see for positively skewed distribution or imbalanced data, mode is not changing, mean is changing significantly, median may change, may not change. Even though it changes, it not necessarily significantly it will be changed, and mode there is no impact if there is no change in the higher number of frequency. Highest number of frequency, if that is not changing, the mode will always remain same. So let me just draw and when the tail will be towards the negative direction, let's say you have very few values which is significantly lower with respect to the rest of the values, rather than having 20 and 30, let's say I have minus 20 and minus 30, that is significantly lower, then the tail will be towards the negative direction. So that is called negatively skewed data. So now I will write down, I will draw three different distributions, skewed distribution along with normal distribution, and I will also write down the condition, and then you will understand for which kind of distribution, which single value, because the measures of central tendency means just by having one value you can understand the nature of data set, or the data distribution. If somebody says for a given data set, mean, media equals to mean, media and mode, all these three are 5. So what is the kind of data it is? Normally distributed, balanced data, absolutely balanced data, right? So let me draw three different distribution, and then it will be again easier for you to understand, but the basics I have already explained, right? Okay, so now you see these three set of observations along with their frequency. First column represents the observation values, and second column represent the frequency, respective frequency for all the tables. Now for these three tables, actually this signifies three different type of data distribution. How this data distribution is depicted graphically, and for each of the data distribution, what is the kind of relationship it is there for mean, median, mode, that also you will understand, right? So let's look into this particular table. So for this set of data, for each tabular data, we will first calculate the mean, median and mode, and then we will reflect those points graphically, and then we will draw the curve, and you will understand what kind of distribution it is there. I will let you know, I will tell you what is the kind of mean, median relationship that you are finding out from here itself, right? So it will give you a clear picture about the data distribution and why mean, median, mode is required, and why these are called measures of central tendency. Okay, so let's say first table. So total number of values, total number of observation, you sum up the frequency. I am not explaining more and again for this same thing, because I explained so many times for mean, median, mode calculation already earlier in videos, and here just for your understanding. For frequency, so what is the formula of mean? Mean, actually we globally universal term for mean, actually that is the mu, it is called mu, that normally we use to indicate mean. So mean equals to each of the observation values along multiplied with their frequency, sum up those numbers and divide the entire summation by the total number of observation or frequency. So what is the total number of frequency or total number of observation for this particular table? It is 10. And what is the summation? So 5 into 1 5, 6 into 2 12, 7 into 4 28, 8 into 2 16, 9 into 1 9. So all these two, if you do the calculation, mean equals to 7. So median is total number of observation 10, so it is even number. There will be two position for median. One is n by 2, that is 10 by 2 5, that is summation of f by 2 5, and summation of f by 2, the total number of observation plus 1, that is the fifth and sixth position. So what is the fifth and sixth position? You don't need to go for another column for cumulative frequency. A lot of people they do that, but what I suggest, you just calculate from here. So fifth and sixth position, first 1 plus 2 3, so 3 plus 4 7, so both fifth and sixth position will come under this part. So fifth and sixth, both the position data, both for fifth and sixth position, the data is 7. So you need to take the average. 7 plus 7 by 2, that is 7. So median is 7. What is the mode? Mode is the total number of highest frequency for which observation value? 7. highest frequency is 4 for observation value 7. So mode is 7. Now if you plot this data, while x is the observation values, it is along the x-axis, and frequency is along the y-axis. All the data points I have plotted here marked in red. If you just join these points, how it will look like? So it's normal distribution. Equally, the numbers are equally. This line, this is 7. This is the observation value 7. So this is mean, median and mode. Mean equals to median equals to mode equals to 7. That already we have calculated here, right? So this point, right side of this point and left side of this point is symmetric. So this is normal distribution. So for normal distribution, mean equals to median equals to mode. Now come to this particular table. Based on this tabular data, what is the total number of total frequency? Frequency is 16. So what will be the mean? Mean will be similarly each observation value along with multiplied by frequency, that it will come to 4.8, right? And median, total number of observations 16, so median will be 16 by 2, and another median position will be 16 by 2 plus 1. That means 8th and 9th position. Same, summation of f by 2 plus summation of f by 2 plus 1. 8th and 9th position. So 8th and 9th position data. So 1 plus 2, 3. 8th position, right? Starting from 3rd position till 8th position, the observation value is 3. Because we have order, for median always you need to arrange the order numbers in ascending or descending order, right? So 1 plus 2, 3, 3 plus 5, 8. 8th position data is 3 and 9th position data is 4. So 8th and 9th position, 3 plus 4 by 2, that is equals to 3.5. So mean is 4.8, median is 3.5. And what is the mode? Highest frequency is 5 and associated observation value is 3. So mode is 3. So now we will put these values in a similar way. X along the x-axis the observation values, along the y-axis the frequency. So now all these points, right? It is, let's say it is 1 1, it is 2 2, this one is 3 5, this one is 4 3, this one is 5 2, this one is 10 2, this one is 15, observation value 15, and the frequency is 1. Now if you join all these points, how the graph will look like? So here you can see this graph is not symmetrical like the normal distribution. And the tail, what I explained, this is the tail. The tail is elongated towards the positive direction. So it is called positively skewed data. So when apart from normal distribution there are skewed data, so it could be positively skewed data or negatively skewed data. So this is what the positively skewed data. So for positive skewed data, what you have noticed, always the mean will be towards the right side, right? So mean is 4.8, right? Here it was 7. In here itself mean is 4.8. 3, 4, 5. So nearby this point the mean will be here. So this is what the mean, 4.8, right? This is what mean. Where the median line it is there, median is 3.5. 1 2 3, 3.5. This is what the median, right? So this is what the median. This line is median. And which is the mode? Highest frequency. This is the mode. Mode we have seen 5. 5 is for 3. This is what the mode. So what you can see, for positively skewed data, mean, you can see from the graph also, mean greater than median greater than mode. So sometimes median and mode also, based on the nature of data, based on the observation values or frequency, median and mode could be equal sometimes, but never mean will be equal to median or mode for positively skewed data. Always mean will be highest and then median and then mode. Normally that's how it happens, right? For not for bimodal or trimodal or multimodal data, there the calculation will be different. Here itself, just for your understanding, I am assuming the mode, there is single mode for each of the data distribution, right? So what you can see from here, for positively skewed data, your mean value, mean is greater than median, which is greater than mode. Mean is greater than median, greater than mode. So positively skewed data, this is what the standard relationship. Mean is greater than median, greater than mode. Right. For now we will go to the next set of data, where it is, there are total number of observation, if you I have calculated, it is 16, right? Now when we calculate the mean, it comes 6.2, median 6.5, because 16 means 8th and 9th position. 8th position means 1 plus 3, 4. I am adding the frequency, 1 plus 3, 4. 4 plus 4, 8. 8th position data is 16, 6. And 9th position data, it is 7. Because starting from 4th to 7th position, starting from 5th to 8th position, the value is, observation value is 6. And from 9th to 13th position, it is 7. That means 8th and 9th position, 8th position data observation value is 6. 9th position data observation value is 7. So 6 plus 7 by 2, that is 6.5. So your mean is 6.2. Your median is 6.5. And what is the mode? Maximum frequency, it is 5. For which observation? That is 7. Value is 7. So mean, median. Now, when we put these values, right? When we put these values here itself, right? Based on this curve, I am putting all the values based on the given observation and frequency. Then I am calculating where is the mean based on the mean itself. Then you can see from the graph also, you are comparing based on your mean, median, mode calculation, that okay, so that is how the relationship, that is the whole purpose of doing this particular video. Why these are called central tendency, and for which kind of data, each of the data, it represents the entire data set, right? So now if I join all these points, so 1, 1, 5, 3, 5, 3, 6, 4, observation value 6, frequency 4, observation value 7, frequency 5, 8, 2, 9, 1, 9, 1, right? Now if I adjoin these points, right? Here you can see the tail is towards the negative direction, right? So it is called negatively skewed data. Or for positive skewed data, sometimes it's called also right skewed data, and this is left skewed data. For negative skewed data, left skewed data. For positive skewed data, right skewed data. The tail tending towards positive direction, positive skewed data, right skewed data. Tail is trending towards left side, towards negative direction, it is negatively skewed data. So here if you see, what is the mean? Mean is 6.2. That means 6.2 nearby, let's say this point. This is what mean. What is the median? Median is 6.5. So this is what your median. And what is the mode? Mode is the highest frequency, that is 7. So this is what your mode. So for negatively skewed data, what you understood? The relationship is mode is highest. For negative skewed data, mode is highest, mean is lowest. For positive, so what is the relationship? Relationship is mean less than median less than mode. So for normal distribution, the relationship is mean equals to median equals to mode. For positive skewed data, right skewed data, the tail is trending towards right side. What is the relationship? Mean greater than median greater than mode. In which direction the tail will be there? Because it is happening because of the outlier. Majority of the values for positively skewed data, it is the lower side. Whereas for negatively skewed data, majority of the observation values on the right side or the higher side, right? So for positively skewed data or right skewed data, mean greater than median greater than mode. And for negative skewed data, mean less than median less than mode. So that means by looking into the mean median mode relationship or any single value itself, you can understand what is the kind of data distribution it is there. If mean median mode is equal, then it is a normal distribution, absolutely balanced data set. If mean is greater than median or mode, that means it's a positively skewed data. And if the mean is less than median and mode, that means it is a negatively skewed data. So that represents the nature. One single relationship or value represents the entire set of data distribution. That is why it is called the central tendency. There are two things: centrally positioned for normal distribution, mean median mode, and all the data points are actually against that measure. So for positively skewed data or negatively skewed data, since the mean is significantly impacted by the observation value, so it is changing abruptly. That is why for skewed data, mean is not the perfect measure. For normal distribution, mean median mode. For single mode, there is one mode for that kind of data. If it is positively skewed or negatively skewed, then actually the median is the better choice to represent the data than mean. And one last point I would like to mention about the limitation of the data set. Since mean and median both calculates the observation value. For mean, it considers all the observation values and summing up after multiplying with frequency. So basically calculation it is there. And for median also, when you are finding out the position of the median and then you are taking the average or you are taking one of the observation value. So both for mean and median, it is applicable for numerical values. Mean is applicable both for continuous and finite data, and mean and median both are applicable for numerical data, but for mode it is applicable both for numerical and categorical data. Categorical data means, let's say the number given, the color, it is the color. Rather than giving the number, I am saying red 1 time, blue 3 times, green 8 times, or let's say apple 5, orange 3. So these are the category. There also you can find the mode, because just you need to look into the frequency for that specific observation value that you need to consider. So whichever has the highest frequency associated value you need to consider. It could be categorical, it could be numerical. So mode is applicable both for numerical and categorical data, but mean and median, it is only applicable for numerical data, not for categorical data. So that is the limitation for mean, median, mode. And why the measures of central tendency, what kind of distribution, by looking into the mean, median, mode relationship, how you can understand the data distribution. That is what I have tried to make you understand. I hope you liked it. So if you liked this video, please click on the like button. And if you would like to have this kind of conceptual video again and again, please subscribe my channel. Thank you very much.